Dr. K. Paranivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on chemistry of environment. So far we discussed about aquatic chemistry, atmospheric chemistry, and soil chemistry. And today we are going to look at some other aspects of minimizing pollution in all these spheres of environment, namely green chemistry. This actually how we can use chemistry for minimizing pollution or preventing pollution. This is a basic concept of this green chemistry. Let's see what are the features of this green chemistry with a few examples. In fact, the concept of green chemistry was introduced by two American, Dr. Anastas and Warner, in the year 1998, and they postulated 12 principles how we can minimize pollution to the environment, and this is popularly called 12 principles of green chemistry. And these 12 principles serve as a guide for practicing chemists in developing and assessing how green a synthesis, compound, a process, a design or technology is. So, any chemist or chemical engineer who follows these 12 principles definitely will end up in minimizing the pollution or completely eliminating the pollution. This is a guiding principle, 12 principle. So, as per the definition, green chemistry is a design of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. So, the focus is hazardous chemical. In the synthesis of any chemical, anything is a hazardous chemical, raw material or solvent, whatever it is, it has to be eliminated. So, it involves the design itself. The earlier process, anything uses hazardous, that should be replaced by a benign chemical substance. So, this is the focus of this green chemistry. Now, we will look at what are the 12 principles one by one. The first one is the general thing, prevention is better than cure. So, it is whatever we do, better to prevent waste than to treat or clean up waste after it has been created, because after generating a waste and treating it is a problem. It is always better to prevent the generation of waste. This is the first principle. Prevention is better than cure, no waste generation, that is a focus. Second one is about atom economy, and in this synthetic process, the synthetic method should be designed to maximize the incorporation of all materials used in the process into the final product. That is called atom economy. Whatever reagents we take, everything should end up in the final product. That is the focus of this one, that is the atom economy about it, because whatever not incorporated into the final product is going to be emerge from the particular company as a waste. That is the main worry. The third principle is less hazardous chemical synthesis. Wherever practicable, synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. Okay. So, this is less hazardous chemical synthesis is a focus of this third principle. Wherever it is, it should be possess no toxicity or little toxicity to human health and the environment. That is a focus. The fourth one is designing safer chemical. Chemical products should be designed to affect their desired function while minimizing their toxicity. That is a safety of the chemical whatever we are going to use. Fifth one is about solvent, because Many chemical syntheses are happening with organic toxic solvent as well as their auxiliary chemicals. This is the focus of this fifth one, that is safer solvent and auxiliaries. The use of auxiliary substances, for example solvents, separating agents, etc., should be made unnecessary wherever possible and innocuous when used. Okay. This is a fifth principle, safety of the solvent. Okay. The solvent also we have to see if possible no solvent or aqueous solvent, and organic solvents should be avoided, especially toxic chlorinated solvents should not be used in this type of synthesis. The sixth one is design for energy efficiency. The energy requirements of chemical process should be recognized for their environmental and economic impacts and should be minimized wherever it is possible. If possible, synthetic methods should be conducted at ambient temperature and pressure. This is a focus because most of the chemical synthetic process require heating as well as require, especially with the gaseous reactants, require pressure. This should be eliminated, and wherever chemical synthesis, just mere A and B addition should yield the product. That is the focus of this one. So, ultimately the energy requirement for this chemical synthetic process can be very much minimized. Use of renewable feedstocks, that is the seventh principle. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable. So, we have to go for renewable feedstock. All the reagent should come from renewable source. Even in the prior one, energy also should come from a renewable source like solar, etc. So, that is one which will not harm environment. The eighth principle is reduce derivatization. Certain chemical synthesis, some functional group we have to protect it. So, protection, protection is a part of the synthetic organic chemistry to protect a functional group, that should be minimized. Okay. Derivatization efforts should be minimized. So, unnecessary derivatization, that is use of blocking groups, protection, deprotection, temporary modification, physical or chemical process of the process should be minimized or avoided if possible, because such steps require addition of reagents and can generate waste. So, whatever chemicals used for this derivatization, blocking a particular group during a synthesis thing, that is protection and deprotection, usually addition of chemicals. Okay. Everything goes as a waste, because that is not part of the atom economy calculation, definitely 100% waste for all this one. So, this should be paid attention again in any synthetic process. The ninth principle is catalysis, about catalysis. Catalytic reagents as selective as possible are superior to stoichiometric reagents. Definitely catalysts play a very good role in synthesis, and wherever possible we have to go for catalytic process compared to the stoichiometric reagent, where usually excess reagent will be employed than the stoichiometric requirement. The 10th principle is design for degradation. Chemical products should be designed so that at the end of the function they break down into innocuous degradation products and do not persist in the environment. This is very, very important one. And for example, you just consider the case of pesticide. We have three type of pesticide: organochlorine, organophosphate and carbamate, organocarbamate. And carbamate pesticides are easily biodegradable, whereas organochlorine pesticide are persistent organic chemical. They remain in the environment and causes lot of toxic problem, whereas carbamate easily undergoes degradation. So, that type of products should be designed. The 12th principle is about real time analysis for pollution prevention. That is, analytical methodologies need to be further developed to allow for real time in process monitoring and control prior to the formation of hazardous substances. This is also one of the important things. In any synthetic process, there is always a byproduct as possible. The byproduct may be toxic. For example, already we discussed about organochlorine pesticide and herbicide. During their synthesis, one of the toxic compound or unwanted byproduct is dioxin, which is much more toxic than all these chemicals, pesticides, etc. So, like this, any dioxin formation is there or something should be monitored always during the synthetic process. This is the 11th one. And the final 12th principle is inherently safer chemistry for accident prevention. During any synthetic process, most of the time one of the unwanted thing is accident happens. Okay? This should be minimized. That is, substances and the form of substances used in a chemical process should be chosen to minimize the potential for chemical accidents. Okay? This is very, very important, including releases, explosion, fires, etc. possible using certain chemicals. So, these type of things should be paid attention, and if possible such type of chemical should not be used in the synthetic process. If unavoidable, then all kind of safety measures should be taken to minimize the accidents. So, these are the 12 principles of green chemistry concept. We will see a little bit more elaboration on this type of pollution, how they are going to help in preventing pollution. So, as we discussed the principle of green chemistry, mainly prevention is better than cure. That is the focus of the first principle. So, only product, no other byproduct or waste material, otherwise treating them is going to be a big problem. So, prevention of pollution is very, very important. Always go to aim for product. That is what tells about atom economy, where all the reagents should be incorporated into the final product. So, that there is no waste at all. Okay. So, this is also paid attention. Atom economy should be close to 100. So, such process are considered to be very green process. Also, the raw material reagents used for chemical synthesis should come from renewable source, not from synthetic aspects. Okay. And energy requirement should be minimum, and even if it is required should come from the natural process. And wherever possible, we have to go for catalytic process. Without catalyst, the reagents requirement, everything is expensive, even including temperature, pressure, etc. can be minimized with the use of catalyst. And chemical products and processes, whatever it is, the product design or the process going to be utilized for the synthesis of the particular product should be easily degradable, and no harm and no hazardous substances involved during the manufacturing of the particular product as well as in the process itself. So, all these things are a guiding principle as a part of this green chemistry. In this is a hierarchy cone. Whenever a synthetic process, any industry is there, we have to pay attention to this. And the R concept, that is replaceable, reduce, recycle or reuse, all these things should be attempted first wherever possible. For example, replace. Any hazardous materials is involved in the current process, the material, the process or inefficient process or non-sustainable components, etc. if it is there, that should be replaced by modifying the existing process. Okay. Because that will always end up in waste generation, especially with the hazardous things, is not good for environment. So, those type of materials should be replaced. This is the first step we have to pay attention in the green chemistry concept. Second one is reduce. Reduce the use of chemical usage as well as energy. Both should be minimized in the synthesis of particular compound. That is the next priority. The third one is whatever you use it, not end up in the product, and those type of material should be recycled in the process again after recovery, or it should be reused somewhere. That we have to find use. So, all this 4R concept is part of this green chemistry. That is why it is also known as the green chemistry, sometime in referred in literature as a sustainable chemistry, because all this R concept, replace, reduce, recycle, reuse, all this is part of the sustainable goal. And after attempting all these things, something is not possible, then that particular waste should be disposed in an environmentally benign way. So, that is a hierarchy of this green chemistry concept. And generally the green chemical synthesis involves to the current process that should be evaluated, and if there is some hazardous things are there, we have to go for alternate synthetic pathways, solvent or conditions. If it is highly demanding condition, temperature, pressure, etc., with the help of catalyst we have to minimize. So, we have to alternate or look for new way of synthesis with elimination of all this hazardous material. And as per the definition and the 12th principle, if you have a analysis of this, and it clearly says it encompasses all aspects and types of chemical process, including the synthesis, catalysis, analysis, monitoring, separation and reaction conditions. Everything is paid attention, and during attention that reduce negative impacts on human health and the environment related to the current state of the art. Your particular process, now what are the current condition, that we have to clearly analyze everything, then replace if required by one, okay, any hazardous material or the conditions are rigorous condition that we have to minimize with the help of catalysts, and any toxic compounds are going to be formed that should be monitored and analyzed in the during the chemical synthesis. And an ideal synthesis one which covers all this component, it should be a simple process, just mere A and B addition, no chemical. That if you just add 2 or 3 reagent, everything incorporated, and if you are getting a final product, that is a very simple process, that is considered as the ideal synthesis, and it should yield 100%. The yield of the particular process should be 100%. That means atom efficiency also 100%, and it should be done with available material, that is a focus of renewable material, and the process should be environmentally acceptable, no wasted reagent, especially atom efficiency and yield 100%, we are not going to get any waste. And as a simple here, one step process, A and B addition, okay, that is what it refers to, simple, and ultimately it should be safe. The reagents whatever we are going to add should not release any chemicals or create accident, that should be safe. So, if any process involve all those things, is considered to be a green synthetic process for manufacturing a particular chemical compound. And the benign synthesis process is usually measured by the term atom economy. This is what used for to assess the benign process. It is designed the synthesis so that the final product contains the maximum proportion of the starting material. Whatever be added should end in the final product. This term was introduced by Barry-Trost in the year 1991, that is the atom economy, and even before the 12th principle of green chemistry concept introduced. Okay. So, the 12th principle concept is also incorporate the earlier and about the atom economy, and because this is considered as a one of the important step, because earlier process all we considered about yield of the particular process. Yield means we focus only on the product. So, whatever wasted byproduct we do not bother. So, atom economy that way is considered to be environmentally benign, okay, and it should yield 100% atom efficiency. Such process considered to be very benign, and it is actually calculated by this atom economy, and normally expressed in percent, is equivalent to mass of the desired product into 100 divided by mass of the total reactants. Whatever we added, everything is a part of this one, and if it is both the denominator or numerator are going to be the same, and we are going to get 100% yield, that is very benign process. So, atom economy actually measure the efficiency of a particular chemical process. We will see with a simple example. As I told you before, the percentage yield was earlier used. There is a theoretical yield and percentage yield, everything based on the theoretical calculation. That is no longer used, even though it is very good for getting an idea about it, but it will not tell about what is the waste it is going to be. Let us consider a simple example of synthesizing ethylene oxide, this particular compound. This can be prepared by the conventional way, what's a chlorohydrin route. Okay. The ethylene is reacted with the chlorine, and this chlorohydrin will be formed, then it will be alkaline hydrolysis, the treating with the lime, you will get the ethylene oxide. This is the conventional method of manufacturing ethylene oxide from ethylene. And if we calculate the atom economy for this process, that is the formula weight of the atoms utilized divided by formula weight of the reactants, everything, and we will arrive at 23. The formula weight of the atoms utilized, whatever marked in the green, okay, this is the final product, and this is the what in the green you can see there, and if you calculate it is only 44. But if you calculate all the formula weight of all the reagents, that is chlorine, water, the starting material and lime, everything, it comes to 189, but the product is only 44. So, the atom incorporated is 44 divided by 189 into 100, that works out to be only 23%, which is very, very poor. And consider the same compound can be synthesized with a catalytic route, direct oxidation of ethylene gas with oxygen in presence of a catalyst, and we will get the product. It is a direct A and B addition, but here with the help of catalyst. And if we calculate here the atom economy, it is 100%, exactly 100%. So, a synthetic process should be like this. Whatever the reagents added, everything gets incorporated in the final product. Okay. So, the atom economy is here 100% here. The other terms used for calculating the environmental benignness is E factor, and another method for the assessment of processing for reduced environmental impact is E factor. It is described as a weight of the waste per unit of the weight of the product, that is a ratio between waste to product. And if we consider pharmaceutical and petrochemical industry, pharma in the E factor value is 25 to 100, it varies, whereas if we consider pharmaceutical industry, very, very low, it is 0.1. Okay. So, pharmaceutical industry is considered to be in this term, in terms of E factor, it is considered to be very good, but pharmaceutical industry, which waste many of these things in terms of calculating the weight of the product to weight of the waste, then pharmaceutical it is more. Similarly, the same oxide process through chlorohydrin and direct hydrolysis also, ethylene oxide also E factor, here it is 2.2. Okay. This is the catalytic route of getting propylene oxide, where it is 0.3 or almost theoretically is 0, but if you go for conventional chlorohydrin route, it is at 2.2. Okay. Another term used in to express the environmental benignness in environmental quotient, EQ, that is, it assesses the assessment of the environmental friendliness based on the nature of the waste. Okay. The EQ value, the Q value is given water 0, sodium chloride 1, and the highly toxic mercury, it is given as 1000. So, the Q value based on the toxicity of the particular compound, water 0, sodium chloride 1 and mercury 1000. So, EQ, the earlier E factor multiplied by this Q will give you the EQ value, and most environmental process will have the highest EQ value. Unfriendly environmental process will have highest EQ value. Both E factor value also will be high, Q value also will be high. So, that is why. So, always you want to minimize waste and avoid hazardous toxic chemical in synthetic process. Another term used is mass index, MI, that is again summation of reagents plus catalyst plus solvent, etc., normally expressed in weight of the kg, divided by desired product, what we want, that is called mass index. Whatever we discussed earlier, it is a reverse of this product goes to the denominator. So, so far we discussed about all these terms, and we will see some of the example for clean process. And generally we manufacture cotton and paper. In both the process, what we do, we use a huge amount of chlorine as a bleaching agent, and use of chlorine, whether it is the gaseous form as a hypochlorite, whatever it is in the cotton industry and paper manufacturing industry, you end up with what is a toxic compound, organochlorine compound, popularly called AOX. This is similar to COD, BOD. It represents the organic chlorine content of this term. AOX, and this is considered as to be toxic. The value should not for wastewater it should not exceed 1 milligram per liter, 1 ppm in developed countries, but in India we don't have a for discharge, but manufacturing industry we have a standard, the AOX value should not exceed. So this is a problem with this industries. So what is done is replacement with environmentally benign hydrogen peroxide, okay, especially with the iron catalyst if you use it, and brings out the bleaching of cotton and paper. So now replacement of chlorine with the environmentally benign hydrogen peroxide is considered to be a good process of environmental clean process. Is one example. So like this there are plenty of examples nowadays available wherever toxic like this chlorine is replaced with the hydrogen peroxide. Similar way there are numerous processes after this population of this green chemistry concept, many replacement have come like this. Even laboratory analysis we use pipette, normally burette and all, very high volume burette 50 ml. Nowadays what is happening is micro pipette, micro burette, everything have come at least 10 times. Smaller version of the pipette and burette are available in the laboratory because that will minimize the waste generated from the laboratory also. And in laboratory analysis again COD test for estimating the organic content of waste water, what is the amount of organic matter present, we normally go for COD BOD combination. BOD is fine. COD, if I look at it, we use highly toxic mercury, silver, and moreover highly corrosive sulfuric acid. All these things are used in the determination of COD, chemical oxygen demand, which is not environmentally friendly. Mostly after determination we discharge and end up with the wastewater, and it is very difficult to remove mercury, silver and all. So instead we can go for TOC, total organic compound, which is very quick instrumental method in which organic matter is oxidized and the carbon dioxide is formed by AR technique, NDR technique as a TOC. Okay. So like this there are plenty of example have come, replacement of COD with the TOC, going for smaller version of pipette burette, and in chemical process this is one example, chlorine replacement with hydrogen peroxide. Like this there are plenty of examples are available. So thoroughly we have to analyze, is there any toxic chemicals are available, then we have to replace that. As I mentioned before, the green chemistry is a pollution prevention technique, and whatever the 12 principles suggested, clearly if you adapt wherever possible, there is no waste is going to be generated from industries, okay. And sometimes difficult, there are possibilities of generating waste, and even if waste is generated, the OR concept we have to reduce, replace, reuse, recover and reuse, recycle. So these are the concept of sustainable chemistry, and if you attempt all those things, definitely in future green chemistry will help to protect the environment. Thank you.